Salam, peace be upon you. In part 1, we agreed on one single primitive letter, phi. Not a substance, not energy, not a thing inside a container, just a cyclic label, something like an angle on a circle assigned to events. In part 2, we refused to call the support spacetime, and we named it X, a minimal patchwork that only allows us to say, this region overlaps that region, so we can speak locally without assuming geometry. In part 3, we installed the first shock. Absolute phi is mute. Shifting phi by a constant does not change meaning. In part 4, we installed the grammar of permission. On some patches, we are allowed to speak with first derivatives. On others, we are not. On some, we can go deeper. On others, the ice is too thin. Now part 5 is where our language finally learns to touch the page. It is the moment a language stops being a list of letters and becomes something you can actually use to say. It changes. The problem is simple to say and surprisingly hard to do, honestly. How do you talk about the change of something that lives on a circle? Because phi is not a number on a line. It is not 3.7. It is a point on a dial, and dials wrap. If you have ever looked at an old analog clock, you already know the trap. Imagine it is 11:59 in the evening, and then 2 minutes pass. Now it is 12:01 in the morning. The change is tiny, 2 minutes. But if you treat the clock face like a number line, and you subtract 12:01 from 11:59, in the dumbest way you can convince yourself something huge happened, because the labels jump at midnight. The clock did not leap backward or forward through the universe. The face wrapped. That is exactly the situation we are in with PP. Is a cyclic label. It wraps. So the usual idea of difference, the usual idea of derivative, is not automatically safe. If you try to do calculus directly on a wrapping dial, you can create fake infinities, fake discontinuities, fake drama, simply because you forgot that the dial repeats. So we need a discipline, a method that lets calculus touch cyclic data without tearing it. That discipline is the facelift discipline, and it is not an optional trick, it is the only honest way. Let me start with a picture you can feel. You are walking up a spiral staircase. If you stand above the staircase and look straight down, what do you see? A circle. One turn, another turn, another turn. Yet from above, it all collapses into a loop. Step after step keeps passing through the same directions. North, east, south, west, again and again. From that top-down view, it looks like you are going in circles. That top-down view is phi the cyclic. Where on the circle are we labeled? But now ask a different question. How high are you? You cannot answer that question from the top-down circle alone. The top-down view repeats. It does not carry the count of how many turns you have made. To know height, you have to unwrap the circle into a line. Step 1, step 2, step 3. A count that keeps going, a number that does not wrap. That unwrapped count is the lift. The lift is what lets you do arithmetic. It is what lets you say, I moved up by 3 steps, even though the top-down view might look like you returned to the same direction. This is the heart of part 5. To speak about change of a circle-valued thing, we temporarily unwrap it into something line-valued. In our language, phi is the circle-valued thing. The temporary unwrapping is called phi tilde, written as phi tilde. And what does phi tilde do? On a chosen patch P, some local region of X, where we have permission to speak smoothly, phi tilde assigns a real number to each event in that patch, a number on a line. Not because the universe is a line, but because calculus lives on lines. Then, when we wrap that real number back onto a circle, when we forget how many full turns happened, we recover phi on that patch. That is the whole meaning of the lift condition. If you wrap phi tilde back onto a circle, you get phi on that patch. In ordinary language, phi tilde is a locally unwrapped version of phi. So the lift is not a new substance. It is not an extra field we added to the universe. It is the scratch paper that lets us compute safely. That is the listener picture. Now, let us make it tight, because this is pure structure zero language. We do not get to be sloppy here. We already learned in part 3 that absolute phase is mute shifting phi by a constant is a change of notation, not a change of meaning. In part 4, we learned we must declare where derivatives are allowed. So now, with the lift, we obey both constraints at once. We choose a patch P where phi is regular enough, at least once continuously differentiable if we want first derivatives, and where it is lift valid. And that phrase, lift valid, matters a lot. Because you cannot unwrap a circle globally if the circle is doing something topologically knotted. Here is the most famous everyday example of that, longitude on Earth. Longitude is cyclic. It wraps around 0 degrees, and 360 degrees are the same direction. If you are at 359 degrees east and you move 2 degrees east, you end up at 1 degree east. The real movement was 2 degrees, but the label jumped across the wrap point. So what do map makers do? They choose a cut. They choose a line where they agree the label wraps. We call it the international date line, but more generally, it is a seam. Then they unwrap the circle into an interval, like minus 180 to plus 180. Now subtraction makes sense locally. Now change in longitude is not nonsense. But notice something. The seam is not a physical tear in the earth. It is not a crack in reality. It is a bookkeeping choice. That is exactly how lifts work. You can lift locally, but you have to be honest about where lifting is possible and where you had to cut. And the reason you sometimes have to cut is not because you are bad at math. It is because the underlying pattern has real topology, real winding that cannot be flattened globally without introducing a scene. This is why the lift discipline is not just math. It is the doorway through which topology starts to speak. Now, before we go there, let us install the firewall gates for part 5. In plain language, the way we promised, not as an outline, but as living hygiene inside the story. First gate, well-formedness. Here is the rule, and it is brutally simple. If you want to take a derivative, you do not take the derivative of the wrapped phi directly. You take the derivative of the lift phi tilde on a lift valid patch. In everyday language, you do not differentiate the clock face. You differentiate the unwrapped time count. Why? Because a derivative is a limit of differences, and difference on a circle is ambiguous near the wrap point, unless you choose an unwrapping. If you have ever edited audio, you have met this without calling it topology. Imagine a waveform that is smoothly rising, and then it clips at a maximum value and suddenly jumps down because the recording system wrapped or saturated. If you compute a derivative across the jump, you see a giant spike. But the spike is not real sound. It is an artifact of the representation hitting a wrap or a ceiling. The lift is what prevents us from mistaking representation artifacts for structure. So the well-formedness gate says, any sentence that contains a derivative symbol must be a sentence about phi tilde, not about wrapped phi. You are allowed to mention phi as the underlying cyclic label, but the moment you say rate, gradient, or derivative, you must be on the lift. Second gate invariance. Here, the lift brings its own subtle freedom. When you unwrap a circle into a line, there is an unavoidable ambiguity. You can always add a whole number of full turns and still land on the same point on the circle when you wrap back. On the staircase, you can call the ground floor height 0, or you can call it height 2 pi, or height 4 pi. From above, the staircase looks the same. The top-down phi does not care. So the lift is not unique. If phi tilde is a valid lift on patch P, then phi tilde plus 2 pi times an integer n is also a valid lift for any integer n. This is not the same as the part 3 gauge shift shifting phi by a constant, though they rhyme. Part 3 said, shifting the entire circle label by a constant changes nothing meaningful. That was about phi itself. Here, the 2 pi times integer ambiguity is about which sheet of the unwrapping line you chose for phi tilde. Both are real redundancies, and both must leave meaning unchanged. So the invariance rule for part 5 is, any sentence you claim is physically meaningful must not depend on which integer term you added to the lift. And here is the beautiful result. The very next object we will build, the derivative of the lift, automatically satisfies this. Because when you add a constant to a function, its derivative does not change. So if we define a as the derivative of the lift, a defined as the differential of phi tilde, then shifting phi tilde by 2 pi times an integer n does nothing to a. This is why the lift is allowed. It produces an invariant derivative object, even though the lift itself is ambiguous. It is like setting a stopwatch. You can set your stopwatch to 0 at any moment. That absolute 0 is arbitrary, but the rate at which it ticks and the time differences it measures are not changed by where you set start. The lift is like the stopwatch 0. The derivative is like the tick rate. Meaning lives in what survives the 0 choice. Third gate domain and guard. This is where we have to be strict, because this is where people cheat without noticing. You cannot lift everywhere. You can lift only on lift valid domains. Typically, patches that are simply connected and free of defects. No holes, no winding obstructions. What does that mean in everyday language? It means you can unwrap the dial only in a region where walking around inside the region does not force you to accumulate an extra full turn when you come back. If you have ever tried to lay flat a loop necklace that has a knot in it, you know the feeling. Locally, you can straighten a small segment, but globally, the knot forces a twist somewhere. You cannot make the whole thing a straight line without cutting. Defects in phi are exactly like knots. There are places where phi winds in a way that cannot be globally unwrapped without seams. So the domain gate says, if you want to use a lift, you must declare the domain where the lift exists. You must say on patch P which is lift valid, we choose phi tilde. If you do not declare it, your sentence is illegal, because you might be silently assuming a lift exists where it cannot. And this is not a minor technicality. It is the difference between real topology and fake discontinuity. Because if you pretend you can lift globally when you cannot, you will create contradictions. You will go around the loop and come back with a different value of the lift, and you will call it a paradox. It is not a paradox. It is you ignoring the domain rule. Fourth gate, non-encodability challenge. This is our discipline against wishful thinking. Someone will always say, surely we can define the derivative of phi directly on the circle without this unwrapping fuss. The language responds, fine, show us. But you must show it in a very specific way. You must produce a rule that is local, meaning it uses only nearby information on the patch invariant, meaning it does not depend on any private choice of zero branch or seam pure structure zero clean, meaning it does not smuggle in extra structure like a metric, a preferred coordinate, or a measurement device that knows absolute phase and equivalent meaning on every patch where a lift exists. Your lift-free derivative must equal the derivative we get from lifting. If you can do all that, then the lift is unnecessary. But the deep reason most attempts fail is the simplest reason. On a circle, you cannot subtract points without deciding which direction around the circle you mean, especially near the wrap. Any rule that decides that consistently is in practice choosing an unwrapping, choosing a lift, whether it admits it or not. So the non-encodability gate is not a debate about taste. It is a formal demand. If you reject lifting, you must replace it with something that does exactly what lifting does without secretly doing it. Now we can state the prediction and falsification of this part, again in the grammatical sense, not in the go run an experiment sense. Prediction. Any attempt to make stable derivative claims while ignoring the lift will either break invariance, meaning it will depend on an arbitrary choice, or it will secretly reintroduce a lift under another name. Falsifier. Produce a lift-free differentiation rule for phi that is local and invariant and equals the differential of phi tilde on every lift-valid domain. If someone can truly do that inside pure structure 0, the lift discipline would be overthrown. But until then, the lift is the clean door calculus must walk through. Now let us make this feel inevitable, not just correct. We have a cyclic primitive. That is what phi is. A map from X to the circle. You cannot do calculus on a pure circle label unless you locally flatten it. And flattening the circle is exactly what the lift is. This is not us adding geometry. It is us respecting the geometry that already exists, the circle's wrapping. You do not blame the circle for being cyclic. You adapt your calculus to it. Now here is where Holophase becomes profoundly coherent with the rest of our arc, especially the tri-unity law we have been carrying since episode 5. Because the moment you have a lift, you can take its derivative. And the moment you can take its derivative, you have created the single object from which time, space, and motion will later be read out together. This is the point where tri-unity becomes unavoidable. Let us say it slowly. We are not allowed to assume time as a container. We are not allowed to assume space as a container. We are not allowed to assume motion as a primitive. We are not allowed to assume a metric, a causal order, a volume form, or any of the usual scaffolding. So where could time, space, and motion possibly come from? They can only come from a public invariant structure derived from phi itself. And the first such structure is the derivative of the lift A, defined as the differential of phi tilde A. Is the first true verb in our language. It is how phi changes in a way calculus can touch. And later, when we learn how to decompose and read A without cheating, we will discover that A always has 3 inseparable echoes. These are what we call omega kappa and nu, cadence texture transport. Not as separate primitives, but as 3 inseparable readouts of one derivative object. So the lift is not just a technical tool. It is the moment the world becomes readable as change. If part 1 was we have one letter, part 5 is we have the first verb. Now let us ground this again in analogies that do not require scientific training, and let us spread them naturally, the way we promised. Think about a melody. A melody often repeats notes across octaves. The note C is C again and again, but at different heights. If you only label each note by its position within an octave, you are using a circle-like label that repeats. Then a melody that rises steadily can look like it is bouncing around because it wraps every octave. So what do musicians do without naming it? They lift. They assign pitch a linear height. This C is higher than that C by 1 octave. They count the wraps. They keep track of the octave number. Now you can talk about the melody rises by 5 steps without being fooled by repetition. That is a lift. Now think about a traffic roundabout. Cars circulate. Their angle around the roundabout is a circle-like coordinate. If you want to measure how far a car traveled along the road, you do not just look at its angle modulo 1 loop. You count laps. You unwrap angle into distance traveled. That count is the lift. The derivative of that count is speed along the path. Again, cyclic label plus lift gives meaningful change. Now think about a rope with stripes painted around it in a spiral. If you look at the rope from one angle, the stripe pattern repeats. But if you trace the stripe along the length, you can count how many times it wraps. That count is a lift. The derivative of that count along the rope is the twist density. And if the rope has a knot, you cannot unwrap the pattern globally without cuts. Topology appears. The same story repeats across scales because the logic is universal. Cyclic data demands unwrapping for calculus. Now let us address a subtle confusion that can sneak in because we have two kinds of shifts in this language and they have different meanings. In part 3, we said phi is equivalent to phi plus a constant. That is the gauge quotient rule. Shift by a constant around the circle meaning stays the same. Here in part 5, we said phi tilde is equivalent to phi tilde plus 2 pi times an integer n. That is the lift ambiguity. Adding whole terms to the unwrapped real number does not change the wrapped value. These are related but not identical. The simplest way to feel it is this. The part 3 shift is like rotating the entire clock face's labeling. You decide that where it used to say 12 now says 3. It is a relabeling of the dial itself. The part 5 shift is like adding or subtracting whole days from your calendar while keeping the same time of day. Noon today and noon tomorrow are the same point on the clock face, but they differ by one full cycle. The clock face cannot see that difference. Only the unwrapped count can. So in this part, we are policing both freedoms, the dial's arbitrary 0 and the unwrapped count's arbitrary number of full turns. Anything physically meaningful must be blind to both. And again, the derivative of the lift is blind to both, because derivatives kill constants and whole turn additions are constants on a patch. That is why this works. Now, what about domains where the lift does not exist? This is where people often panic and think the theory is breaking. But in holophase, it is the opposite. This is where the theory becomes honest. If you cannot lift globally, it is not because the universe is inconsistent. It is because the universe contains a topological obstruction, a winding, a defect, a hole. And the right response is not to invent a new primitive. The right response is to respect the domain gate and adjust your patchwork. You either work on smaller patches where a lift exists, or you introduce a cut, a declared seam, so that the remaining region becomes lift valid. And here comes a powerful insight that will matter immediately for the next part. Cuts are not physical wounds. They are bookkeeping seams. Physics must not depend on where you place them. Just like the international dateline is not an actual scar in the ocean. Just like where you start counting steps on the staircase is not an ontic feature of the building. So the lift discipline naturally sets up the next firewall, branch cuts and their movability. But we will not do that yet. We will only prepare the listener's intuition. If you cannot unwrap globally, you will have to cut. And then you must prove your conclusions do not depend on the cut. That is next. For now, we hold the lift discipline itself. So let me say the full story of part 5 in the simplest, tight form, without losing the rigor. Phi is a circle. Label circles rep. Calculus uses subtraction and limits. Subtraction on a wrapped circle is ambiguous, unless you unwrap it. So on a lift valid patch, we choose an unwrapped version, phi tilde, that lives on a line and wraps back to phi. That choice is not unique. You can add any whole number of full turns and you still describe the same phi. Therefore, any meaningful sentence must be invariant under that choice. The derivative of the lift A, defined as the differential of phi tilde, is exactly such an invariant. It forgets whole term ambiguity and forgets constants. This A is the first public change object in our language, and it is the single root whose readouts will later appear as the inseparable triunity of cadence, texture, and transport. Any attempt to differentiate phi without lifting must either smuggle in a lift or fail invariance. Therefore, the lift is the only honest doorway through which calculus can touch cyclic order. That is the rigorous spine. Now let us give the listener one more concrete memorable scene, something they can carry in their body. Imagine you are in a dark dome. Around the dome is a perfect circular ring of tiny lights, like a halo. A pattern of brightness moves around the ring. You can see how the brightness varies as you go around, but there is no marked start point on the ring. No label that says this is 0 degrees. It is a plain circle. You want to describe how the brightness pattern changes as you move along the ring. To do that, you pick a point and you say, I will call this point the start. Then you unwrap the circle into a line segment from start to start again, and you measure changes along that line. That unwrapping is your lift. If someone else picks a different start point, they will get a different unwrap description. But if you both compute something truly structural, like how quickly brightness changes locally, your answers will agree. The structural claims are blind to the arbitrary start point. That is the phase-lift discipline in one image. We choose a seam to make subtraction meaningful, and then we only trust statements that do not depend on where we put the seam. Now let us put the firewall right into the listener's hands. If you ever catch yourself saying the derivative of phi without mentioning a lift, you have almost certainly cheated. You have either assumed an unwrapping without naming it, or you have defined a derivative that will break at the wrap, or you have defined something non-local that depends on global choices. The Holophase language does not allow quiet cheating. It forces you to show your work. And this is what makes it powerful. Because later, when we build towers of derivatives, when we build jets, when we build topological charges, when we build objects and tallies and meaning, we will know exactly what is real and what is bookkeeping. We will know what survives shifts, what survives lifts, what survives cuts. That is what firewalled means at pure structure 0. Now, we also promise to keep energy framed correctly if it naturally appears. Here it appears as a comparison. In old physics, energy often gets treated like a substance. But we locked in long ago, energy is a tally. It is a report of change, not an ontic brick. The lift discipline is the same kind of humility applied one level deeper. Phi tilde is not ontic. It is not a new substance. It is a tally supporting scaffold. It is the way we can compute change reliably. Just as energy is not a thing, but a report. Just as geometry will not be a container, but a report. The lift is not reality. It is our way of reading reality without lying. Now to close part 5. The way our structure rule demands, we seal one memorable carry-forward sentence, and we bridge naturally to the next part. Here is the carry-forward sentence. To measure change on a circle, you must temporarily unwrap it into a line, and then you must only trust what does not depend on how you unwrapped it. And here is the bridge to part 6. Now we face the honest complication. Not every region can be unwrapped in one piece. Sometimes phi wins, sometimes the domain has holes, sometimes defects force the unwrapping to tear. So next, we will learn the grammar of the tear that is not a tear. Branch cuts, declared seams that make lifting possible, and the strict rule that the universe must not care where we place them. Because if our language is going to build a cosmos, it must stay immune to our bookkeeping choices. Always. Peace be upon you.